So I've been writing web-based apps for my students to use for data collection. My goal is to increase the speed and accuracy of data entry by providing my students with an online interface for data collection. I teach introductory statistics at American University in Washington, D.C. I'm trained as a mathematician, so I also teach math courses and computer science courses. I've been writing web-based apps for various sorts for my students to use since about 2013, or about 4.5 years. My objective for this talk is to encourage you to try this if you are interested. I'll go over some of the benefits of online data collection, as well as some advice on how to get started, and also look at some project results. Why collect data online? Many of you can probably answer this better than I could. Paper gets lost. I've even asked students to take photos on their phones and email the data just until they can get the paper copy to me. They try, but the photos are often blurry or the edges are cut off. Paper documents and shared spreadsheets can contain insane internal inconsistencies. Sometimes there are just incomprehensible responses due to spelling issues. When my students collect data online with my apps, they can use any web-enabled device they want to report the data. This is not a multi-step process. They simply observe and record, and I instantly have access to it. Time is recorded perfectly because the system provides that, not the student. Larger data sets can be collected, and collected faster. The cleaning process is faster. One thing you can do online, which is impossible with paper, is you can find a typo or other glaring error in your survey form. Once you've sent your students out, you can fix it. If you've done that in paper, you can't fix anything. When your survey is online, you can fix small typos. Or if you have the case of a major error, you can actually fix the app and just throw away your early data. There's no better time to start. When I wrote my first app for my students, I tried using Java, and I quickly found out that most of my students couldn't get Java to work. The ones who did said they had to find a computer lab that was running Java. So I scrapped that idea and switched to JavaScript, and suddenly it worked on all platforms, including their phones. In 2013, I would estimate about half of the students were walking around with smartphones at all times. But now, students bring their devices to class all the time, so I don't have to tell them in advance, hey, bring your computer. They always have them with them. As a side note, you might think that since smartphone use has skyrocketed, the students would be more connected than ever. This isn't as true as you might think. They all have the phones now, but fewer of them have laptops. Some of them even try to write term papers on their cell phones. But the takeaway from all this is whatever you put up online, they will probably be on their phones trying to look at it. So keep that in mind when you design it. I can hear some of you thinking, but I've never written a web page. That's okay. Just jump right in with both feet and don't worry about it. You're not a huge corporation, and you're not spending lots of money for bad advice about your website. The things that you as an amateur will write for your students will fit their needs very nicely, and it will have a low use barrier because you won't put self-launching videos and pop-ups and flash and complex graphics in it that will take forever to load. All this stuff you won't do, so your website will be light and easy for your students to use, and they appreciate that. They live online, so when you write pages for them, you're just going where they are. Let me show you how easy it is by giving you an example. This app allows you to record your weight on one of two different scales. It lets you record daily measurements at home and weekly measurements at a weight loss clinic. By the way, all the apps I'm showing you today are up on my website so you can look at them. I'm not using them to collect data anymore, so I've just stored off the actual data somewhere else, and the new logs are just garbage data, so they're there for you to play with. This simple app contains the two elements I use most in my logging apps. You've seen them before, but you may not know what to call them. The first thing is called a text box. It just gives you a little box to type into. The second thing is a set of two radio buttons. These little circles here are called radio buttons. Since they are paired, only one can be checked at a time. And all that programming to make that happen, that's all native to HTML. All you need to do is give the two buttons the same name, and HTML does all the hard work for you. And this is what data will look like. This is real data. You can see the blue dots are the daily readings, and since there are more of them, they tell a more complete story, and therefore a better story than the red weekly dots. If you take readings weekly, the best you can do is play connect the dots from week to week, and this person might become discouraged. For example, Between dots 7 and 8, it looks like there's been a huge weight loss that week, but the next week doesn't look so great. But it's just because of the noise in the measurements. The weight loss didn't really speed up and slow down, and you can go nuts trying to figure out why the weight loss sped up or slowed down. But if you have loads of data, you can see that the overall trends are just a continuous downward trend. And you won't go nuts trying to find information where there's just measurement error. Which goes back to my main idea. When you can take more data, more easily, faster, more frequently, all other things being equal, you will have a better data set. And you can do this very easily online, because you never have to worry about where you put your logbook. You simply grab any device that happens to be lying around and log your data. This is the actual code that runs the previous app. See how small it is? It's just 2 little text files. And this is the logbook format. I like to use time in seconds because it's easier for me, but you should use whatever format is best for your needs. I took this text file and saved it into my computer and asked my spreadsheet to open it as a space-separated CSV file. And I know you're all good to go from that point on. You've done this part a million times, right? And you can have this, and you can just dump it onto your own website, and it can be your first app. And then you can adjust everything to your own needs. You can give a little radio button 3 choices instead of 2. You can add a second set of drop-down buttons, a second set of radio buttons, whatever you want. To get this to work, you'll need a tiny bit of HTML, a tiny bit of JavaScript, and a tiny bit of PHP, all of which I'm happy to give you. You need a place to host this from, but it's not usually expensive. In my case, I pay about $50 a year, but if I buy 3 years at a time, I usually get a discount. So it's even cheaper than that. It's easy to get free websites if you just want HTML and JavaScript, but if you want PHP, you're probably going to have to pay for it, and that's what you need if you want to do logging. One caveat is that you still need a backup plan. There will still be need of paper, sad to say, but that's because sometimes where you go, the internet just doesn't work. In my case, whenever I do surveys on campus, I don't provide paper backups because our internet is reliable enough on campus. But if they're going off campus, then I do provide paper backups. Then I ask them to log the information themselves once they're back. And depending on the project, I might ask for the paper copy for my records. And now I'll show you some examples. This is the first app I wrote to collect an observational study, and this one I did myself. I wanted to work out the bugs before getting my students involved. For this little study, I decided to look at how temperature affects what people wear and how much skin they expose. This is the app. You can see it's mostly made up of radio buttons and a couple of drop-down menus. Each row of buttons is a group together. For example, I record whether the person has long sleeves, short sleeves, or no sleeves. I record whether they're wearing shorts, mid-length pants, or a skirt, or long pants. And I have a place for comments. For example, I can say, erase that last log entry, that was a mistake. And then I'll just erase it later when I'm cleaning the data. I got lots of nice data. I had about 865 observations, which I collected over about 2 weeks. It was easy to collect, easy to clean, and easy to process. I got tons of nice graphs and charts. This is the most fun result. When it's colder, the women on our campus bundle up more than the men, but when it's warm, that reverses. And this reversal happens at about 10 degrees centigrade. And this is pretty cool too. As you might expect, the college-age bunch exposed more and faster than the middle-aged or older people. The middle-aged and older people were indistinguishable statistically. So I was encouraged by that study and designed a new one for my students. I asked them to pick a public location such as a grocery store or metro, that's like our subway or underground, or they could go to a public shopping plaza. Then they were to record gender, age bracket, race, and whether or not they thought a person was an employee. And this is what the app looks like. The students would fill in the text boxes upon arrival at the location, but they would only have to fill that part in once. So this is the view they would spend most of their time on. Each observation requires between 2 and 5 finger clicks on their device. So let me give you an example of how that works. Here I've selected a middle-aged female customer who appears to be Asian or of Asian descent. I click the submit button, and that takes me to the confirmation page, where if I want to see the log, I can click on the log to see what it looks like, or I can just hit the back button. And that will take me exactly back to the previous page I was on. So if there are two middle-aged Asian females shopping together, I can just hit submit again and I've logged the second person. However, if this person is actually with her daughter, I can just move the age button over to child and then resubmit that. So you see, with a group of people together, usually either the age category is the same or the gender is the same, so you don't have to change all the options each time. This makes the collection really fast. In some instances, you don't have to take a random sample because you can actually record everyone in the entire store. This gets rid of unintended bias because you're able to grab a better sample. If you're doing this sort of thing outdoors, you can mentally draw a line on the ground and just record every single person who steps over that line. But this is great because you don't have to worry about your own bias creeping into which people you choose to record. Here are just a few little results to look at. These are some pie charts for racial composition at 2 metro stations in DC. We had 35 or 36 locations, and this is just the racial data from 2 locations. You can run through data with typical questions like here I just said, hey, what about a chi-square with gender versus race? And I was not expecting this at all. And you can have your students do this sort of thing. Play with the data, see what fun things they can find. It looks like for African Americans, we see males and females in equal numbers, but for Asians, this isn't the case. That's weird. I wonder what's happening. Perhaps it's all about the groceries. I don't know. We noticed there were more women in the grocery stores than men, and we had more grocery store observations than any other category just because that's where the students chose to make their observations. They saw about 300 men in the grocery stores compared to about 400 women. The cleanest data set I got was from my students on this study. I had them pick nearby colleges and universities and go in groups of 2 or 3, ask the students how they felt about food options in and around their campus. I sent them in groups partly for safety but also to discourage data fabrication. This is what the app looks like. They just use the drop-down menu to choose their location, then they click on the stars the same way you would use a radio button, and it works basically the same way as my other apps. The conclusion was not to eat near UDC. Georgetown, George Washington, and University of Maryland all came in with no statistical difference, but UDC was definitely worse. I actually do try to cover ANOVA in my intro course, but only briefly and only at this very high level. So my students should be able to understand that this is an extension of what we do with t-tests for 2 samples. They will look at the p-values from this output that I generate, and hopefully they'll be able to draw this simple conclusion. So what about entry errors? I was hoping I could completely eliminate data errors, right? Of course not. The computer does restrict data entry errors, but it does seem that humans are very creative and still find ways to introduce entry errors. It seems there are fewer errors with simpler studies, but that could just be an illusion. I can't tell. And for my last example, my favorite study, the favorite data set I collected was from students I did on campus last fall. Some of you might be aware that in our country we elected a new president last fall. I wanted to find out if students on our campus had issues with voting. Just as a rough estimate, about 20 million of the 250 million eligible voters will be attending college that fall, so roughly 8% of the voting population. Class year didn't seem to matter statistically, which is great because I didn't actually weight my results, and you can see that we did not have equal representation from the different class years. This is what the app looks like. I have my students collect surveys from anyone who wanted to participate. Emotions were running very high around this election, and I did not want anyone to feel left out, like we didn't want to hear about their experiences. So we collected the surveys, but then tossed out results from anyone who was a non-citizen or a non-AU student. On our campus, students tend to be outspoken about their politics. One of my students actually worked for the Clinton campaign for over a year. Most students are Democrats or independents. Even the Republican club on campus is somewhat left-leaning. But college campuses in rural areas have vastly different political climate than campuses in large cities. Where I used to teach in rural Pennsylvania, the students were mostly Republicans, and there was some stress between them and their professors about politics. Of the 385 AU student citizens in our survey, 332 of them said they voted and 15 of them did not reply. So at least 86% of them were able to vote. 49% voted by mail, 12% voted early, and 32% voted in person. 20 students said they didn't care to vote, but they did anyhow. And by reading the comments, it was mostly because a friend, parent, or professor pressured them into doing it. However, what was concerning to me is that we had 21 students who said they wanted to vote, but they were unable to vote. Since half of our students voted by mail, was there an issue with the absentee ballots? Well, 33 students said they never received the absentee ballots they had requested. 43 students indicated they made multiple attempts to get those ballots. Of course, what's the overlap? Well, the overlap was 5. So 5 students tried multiple times and still did not get their absentee ballots. This is really shocking. That's saying more than 10% of our students tried to get absentee ballots and failed to do so. I mean, almost 10%. Whoops. So I decided to look more closely at those surveys from those 33 students. Shockingly enough, all 5 of those students did end up voting. 3 of them said they had to travel, but they all said they voted. This is encouraging. And for the other 28 who never got ballots, there were 2 non-responses on the voting question. But we do know that 19 of them ultimately voted and 7 of them didn't. So where does that leave us? 7 or 8 students out of 385 is about 2%. U.S. elections can ride on very fine margins, often even in a single state. Missing votes from college students could be playing a role in U.S. elections. In conclusion, data can tell a complex story. Other things being equal, the larger your sample, the better your chances of capturing an accurate story. Taking the collection online increases the speed, cuts down on many of the errors, and can improve your data and your results. All the apps I just showed you are available on my site for you to play with, and if you want the PHP code, just send me an email and I'll give them to you. Are there any questions?